Voyager 1 has been humanity's most distant messenger for over 4 decades, traveling through the cosmic void at 38,000 miles per hour and sending back data from regions no human has ever seen. But here's what will blow your mind. This 1970s spacecraft, built with less computing power than your smartphone, just detected something moving in interstellar space that has NASA scientists working around the clock to understand what they're looking at. The mysterious signal. Voyager 1 just sent back data that has NASA scientists working around the clock, and what they discovered 14 billion miles from Earth is keeping them awake at night. Deep in the cosmic void where no sunlight has touched anything for billions of years, something is moving with purpose and intelligence that defies every law of physics we understand. The signal first appeared as an anomaly in Voyager's plasma wave readings, a rhythmic pattern that shouldn't exist in the empty darkness between stars. But here's what's really unsettling. When scientists ran the data through every possible filter and diagnostic test, they realized this wasn't equipment failure or cosmic interference. This was something real, something structured, and something that seemed to be tracking Voyager's movement through space. The electromagnetic signature doesn't match any known celestial phenomenon, and its behavior patterns suggest a level of complexity that has researchers questioning everything they thought they knew about interstellar space. What makes this discovery even more extraordinary is that the signal appears to be responding to Voyager's presence, almost as if it recognizes the spacecraft as something foreign in its domain. For the first time in human history, we may have encountered something in the depths of space that operates by rules we haven't discovered yet, and it's been watching us from the shadows of the cosmos. Voyager's journey beyond the planets. Right now, as you're watching this video, there's a piece of human technology hurtling through absolute darkness at 38,000 miles per hour, farther from home than any object in human history. Voyager 1 crossed the boundary into interstellar space in 2012, becoming humanity's first ambassador to the galaxy beyond our solar system. But here's what most people don't realize. This region was supposed to be cosmic wasteland, a barren void containing nothing but scattered hydrogen atoms and ancient starlight. Instead, Voyager has been sending back data that's completely rewriting our understanding of what exists in the space between stars. The spacecraft is now over 14 billion miles from Earth, traveling through a realm where our sun appears as just another faint star and temperatures hover mere degrees above absolute zero. This is a place where radio signals from Earth take over 22 hours to reach Voyager, and every piece of data it sends back is like a message from another dimension. What makes this journey even more remarkable is that Voyager was never designed to survive this long or travel this far. It was built for a 4-year mission to Jupiter and Saturn. Yet here it is, decades later, exploring the cosmic frontier and discovering that interstellar space is far more dynamic and mysterious than we ever imagined, setting the stage for encounters that challenge everything we thought we knew about the universe. Unexpected movement detected. Something is defying the laws of physics in the coldest, emptiest region of space, and it's moving in ways that have scientists questioning everything they thought they knew about how objects behave in the cosmic void. The movement Voyager detected wasn't the predictable drift of space debris or the gravitational dance of celestial bodies. This was something actively changing course, accelerating and decelerating with patterns that looked disturbingly intentional. When the data first arrived at Mission Control, engineers thought they were looking at corrupted telemetry because objects simply don't behave this way in interstellar space. But after months of analysis and verification, they realized they were witnessing something unprecedented, an object that seemed to be making deliberate course corrections billions of miles from the nearest star. The movement patterns showed periodic velocity changes that couldn't be explained by solar wind, magnetic fields, or gravitational influences from distant stars. What's even more unsettling is that the object appeared to be adjusting its trajectory in response to Voyager's approach, almost as if it was aware of the spacecraft's presence and reacting accordingly. Scientists have run the data through every known model of celestial mechanics, and nothing comes close to explaining what they're seeing. This isn't random motion or natural orbital mechanics. This is controlled movement in a region of space where nothing should be able to control anything, challenging our fundamental understanding of what's possible in the vast emptiness between stars. Not a planet, not a comet. Every single explanation in our cosmic playbook has been crossed off the list, and what remains is something that shouldn't exist according to everything we know about space. Scientists have spent months systematically eliminating every possible conventional explanation for this mysterious object, and each elimination has only deepened the mystery. Planets don't roam freely through interstellar space, and even the rare rogue planets that get ejected from their star systems follow predictable gravitational trajectories that this object completely ignores. Comets are ruled out because they develop distinctive tails and comas when exposed to stellar radiation. But there are no stars within light-years of this object's position to trigger such activity. The spectral analysis shows none of the rocky signatures we'd expect from an asteroid, and its complex movement patterns are far too sophisticated for a simple chunk of space debris drifting through the void. Even exotic celestial bodies like brown dwarfs, neutron stars, and white dwarfs have been eliminated because this object doesn't emit the characteristic radiation signatures that would identify it as any known type of stellar remnant. What's left is something that behaves unlike any natural phenomenon we've cataloged in our centuries of astronomical observation. The object's ability to change course, its apparent awareness of Voyager's presence, and its structured movement patterns have pushed scientists into uncharted territory where conventional astrophysics offers no answers, forcing them to consider possibilities that challenge the very foundations of what we believe exists in the cosmos. Theories behind the movement. The world's leading astrophysicists are proposing theories that sound more like science fiction than peer-reviewed research, and that alone should tell you how extraordinary this discovery really is. One of the most compelling hypotheses suggests we might be witnessing our first direct encounter with dark matter structures that interact with normal matter in ways we never predicted, creating movement patterns that appear almost biological in their complexity. Another theory proposes that this object represents evidence of exotic physics operating on scales we've never observed before, possibly involving magnetic field interactions or quantum effects that only manifest in the extreme conditions of interstellar space. Some researchers have suggested we might be looking at a completely new type of celestial body formed by processes that don't exist anywhere in our solar system, perhaps created by the collision of cosmic phenomena we haven't discovered yet. The most controversial theory, whispered in academic circles but rarely published, is that we might be observing technology of non-terrestrial origin, something that operates by principles we haven't mastered or even understood. What makes this theory particularly unsettling is that the object's behavior patterns show characteristics that some researchers find impossible to explain through any known natural phenomenon. The structured movement, the apparent responsiveness to Voyager's presence, and the sophisticated course corrections all point to something that operates with a level of complexity that challenges our understanding of what's possible in the vast emptiness between stars. Voyager's instruments and their role. 47-year-old technology designed during the Nixon administration is currently making the most groundbreaking discovery in human history. And the irony isn't lost on the scientists analyzing the data streaming back from the edge of known space. Voyager's scientific instruments, built with 1970s computing power that's millions of times less sophisticated than your smartphone, have somehow become humanity's most advanced deep space detective system. The plasma wave instrument has been crucial in detecting the electromagnetic signatures that seem to pulse in rhythm with the mysterious object's movements, creating patterns that resemble communication more than random cosmic noise. Meanwhile, the magnetometer has revealed magnetic field fluctuations that correlate perfectly with the object's position changes, suggesting it's either generating its own magnetic field or manipulating the existing interstellar medium in ways we've never observed. Most remarkably, the cosmic ray detector has shown that this object is somehow creating a shadow in the cosmic radiation background, deflecting high-energy particles in a manner that suggests it has mass and structure far beyond what its other signatures would indicate. These instruments weren't designed to detect artificial objects or analyze unknown phenomena. They were built to study planets and measure solar wind. Yet they're providing us with data about something that operates by rules we haven't discovered, proving that sometimes the most extraordinary discoveries come from tools we never expected to make them. The distance and speed of the object. At this very moment, something is racing through the cosmic void at speeds that would make our fastest rockets look like they're standing still, operating in a region of space so remote that light from our sun becomes just another dim star in an ocean of darkness. The object was first detected when it was approximately 500 million miles from Voyager 1, which means it's functioning in a zone where the nearest star system is still over 4 light-years away, a distance so vast that even traveling at the speed of light, it would take 4 years to reach the closest stellar neighbor. What's absolutely mind-blowing is that this object has been clocked moving at roughly 26,000 miles per hour, relative to Voyager's position. But here's where it gets really weird. That speed isn't constant. The object has been observed accelerating and decelerating in patterns that suggest it's not just drifting through space like a piece of cosmic debris. To put this in perspective, even our most advanced spacecraft would require tens of thousands of years to cover the distances this mysterious object has traveled. Yet it's doing so while making controlled course corrections that defy everything we know about how objects move through interstellar space. The fact that something can demonstrate such apparent control over its movement at these incomprehensible distances and speeds raises profound questions about what we're actually witnessing in the deepest, darkest corners of our galaxy. Why scientists are intrigued. The most brilliant minds in astrophysics are losing sleep over data that's honestly forcing them to question 40 years of established science. Some are even privately admitting they might need to rewrite the textbooks on what actually exists in interstellar space. This discovery isn't just another interesting anomaly that scientists can, file away and study later. It's actively challenging fundamental assumptions about the very nature of the cosmos that have guided space exploration for decades. For generations, we've operated under the comfortable assumption that the vast regions between stars are basically empty highways, where objects follow predictable paths governed by well-understood gravitational forces. But this mysterious object is behaving like it has its own agenda, moving with a kind of purpose and intelligence that suggests interstellar space might be way more populated and active than we ever dared to imagine. What's really keeping researchers awake at night is the realization that if one object like this exists, there could be thousands or even millions of similar phenomena operating in the cosmic shadows, completely undetected by our Earth-based telescopes. The implications here are just staggering. We might be living in a universe that's absolutely teeming with activity we've never noticed, surrounded by phenomena that operate by physical laws we haven't even discovered yet. This single detection has opened a door to possibilities that range from revolutionary physics to, honestly, the unsettling prospect that we're not alone in ways we never considered, fundamentally changing how we view our place in the cosmic order. Potential implications for space exploration. The discovery that's currently sitting on classified desks at NASA headquarters could, completely revolutionize how we design spacecraft and plan missions to the stars. The implications are so profound that space agencies around the world are quietly restructuring their long-term exploration strategies. If this mysterious object represents a new category of interstellar phenomena, it means that the space between stars is far more complex and potentially hazardous than we've been preparing for, forcing engineers to totally rethink how future deep space probes will navigate and survive in regions we thought were predictably empty. The object's apparent ability to manipulate its environment and respond to external stimuli suggests that interstellar space might contain active systems that could either help or hinder human exploration efforts in ways we never really anticipated. From a technological standpoint, understanding the physics behind this object's movement capabilities could unlock propulsion concepts that would make our current rocket technology look, honestly, pretty primitive, potentially reducing interstellar travel times from tens of thousands of years to mere decades. Even more intriguing is the possibility that this discovery could lead to breakthroughs in energy manipulation and field generation that would revolutionize not just space travel, but technology here on Earth as well. The fact that we stumbled upon this phenomenon by accident just highlights how much we still don't know about our cosmic neighborhood, suggesting that future missions equipped with more advanced detection systems might encounter similar objects regularly, fundamentally changing our approach to exploring the galaxy and our understanding of what's possible in the vast ocean of space surrounding our solar system. What could it really be? After exhausting every conventional explanation and running the data through every known model of physics, we're left staring at 3 possibilities that would each, honestly, fundamentally change humanity's understanding of our place in the universe. The most conservative scientific explanation suggests we've discovered a completely new type of interstellar object. maybe a category of celestial body formed by exotic processes that don't exist anywhere in our solar system, operating by physical laws we haven't identified yet. A more radical possibility is that we're witnessing our first direct encounter with dark matter structures that can interact with normal matter in ways our current theories never predicted, creating organized movement patterns that appear almost alive in their complexity. But here's the explanation that's being whispered in research facilities around the world, the one that keeps appearing in classified reports. Despite scientists' reluctance to discuss it publicly, we might be observing technology of non-human origin. The object's structured movement patterns, its apparent responsiveness to Voyager's presence, and its ability to make controlled course corrections in the vast emptiness of interstellar space, all point to something that operates with a level of sophistication that, honestly, challenges every assumption we've made about what exists in the cosmic void. Regardless of which explanation proves correct, this discovery represents a watershed moment in human history. The moment we realize that the universe is far stranger, more populated, and more mysterious than we ever dared to imagine, forcing us to confront the possibility that we're not alone in ways we never considered. So there you have it, Voyager's incredible discovery that's honestly challenging everything we thought we knew about interstellar space. Whether this mysterious object represents unknown physics, a new type of celestial phenomenon, or something even more extraordinary, one thing is certain: we're living through a moment of genuine cosmic mystery. What's your theory on what this object could be? Drop your thoughts in the comments below. I really love hearing your perspectives on these space mysteries. If you enjoyed diving into this cosmic puzzle, make sure to subscribe to Simply Science and hit that bell icon so you never miss our latest discoveries from the final frontier. Thanks for exploring the universe with us. Fresh observations of 3I Atlas are now shedding light on this mysterious interstellar visitor, and what scientists are discovering challenges everything we thought we knew about cosmic wanderers. With a trajectory that defies astronomical odds and behavior patterns unlike any natural object, this ancient visitor raises profound questions about its true nature. Could humanity be witnessing something far more extraordinary than just another comet? Discovery and initial detection. What if the most significant discovery in human history almost slipped past us unnoticed? 3I Atlas was discovered on July 1, 2025 by the Atlas telescope in Chile, initially receiving the mundane designation A11PL3Z before astronomers realized they were observing something unprecedented. This marks only the third confirmed interstellar object after Oumuamua in 2017 and Borisov in 2019, making it an extraordinarily rare cosmic event. The object had actually entered our solar system much earlier, but its challenging viewing angle near dense star fields delayed detection until it was already well within the inner solar system. Late detection meant crucial observation time was lost, similar to what happened with Oumuamua, when humanity missed the opportunity for detailed study. The discovery team quickly recognized unusual motion patterns that didn't match typical solar system objects, prompting immediate follow-up observations from telescopes worldwide. Within 24 hours, NASA confirmed its interstellar status, officially designating it as C/2025N1 and awarding it the historic 3Y designation. This rapid confirmation process demonstrated how much astronomical detection capabilities have improved since Oumuamua's controversial discovery 8 years earlier. Extraordinary orbital characteristics. How can an object's path through space defy the very laws of probability? 3I Atlas follows a hyperbolic orbit with an extreme eccentricity of 6.14, the highest recorded among all known interstellar objects, far exceeding Oumuamua's 1.2 and Borisov's 3.6. This incredible trajectory brings it racing through our solar system at 58 kilometers per second, making it the fastest interstellar visitor ever recorded. Most remarkably, its trajectory lies almost perfectly in the ecliptic plane, with astronomers calculating only a 0.2% probability of this occurring by random chance. The ecliptic alignment means the object travels along the same plane where all planets orbit, providing optimal viewing opportunities for studying multiple worlds during a single passage. This path appears deliberately designed for comprehensive planetary reconnaissance, rather than the random trajectory expected from a natural ejected object. The orbital mechanics suggest the object has maintained this precise alignment throughout its potentially millions-year journey through interstellar space. Such mathematical precision in trajectory raises fundamental questions about whether natural gravitational interactions could produce such an unlikely path. The combination of extreme speed, perfect ecliptic alignment, and record-breaking eccentricity creates a statistical anomaly that challenges conventional understanding of interstellar object behavior. Suspicious planetary encounters. What are the odds that a random space rock would visit exactly the planets most interesting to an alien intelligence? During its passage through our solar system, 3I Atlas approaches unusually close to Venus, Mars, and Jupiter, with astronomers calculating the probability of such precise planetary encounters at just 0.005%. The object passes within 0.65 astronomical units of Venus, 0.19 AU of Mars, and 0.36 AU of Jupiter, distances that would allow detailed study of each world's atmospheric composition, magnetic fields, and potential habitability. Perhaps most intriguingly, its closest approach to the Sun occurs precisely when Earth is positioned on the opposite side, blocked from direct observation during the most critical phase of its visit. Scientists estimate only a 7% probability that this solar eclipse timing would occur naturally. The trajectory resembles a carefully planned reconnaissance mission designed to gather maximum information about our solar system while minimizing detection risks. Each planetary encounter occurs at optimal distances for advanced sensors to collect detailed data without triggering obvious gravitational perturbations that might reveal artificial propulsion systems. The visiting pattern suggests intelligence rather than random cosmic wandering, following protocols that hypothetical alien explorers might use to study potentially inhabited star systems. This systematic approach to planetary surveys raises profound questions about the object's true purpose in our cosmic neighborhood. Physical properties and anomalies. How can something be simultaneously ancient beyond imagination, yet perfectly preserved for scientific study? Recent observations by the Vera C. Rubin Observatory reveal that 3I Atlas measures somewhere between 1 and 12 kilometers in diameter, making it, well, significantly larger than previous interstellar visitors, and potentially the biggest object of its kind ever observed. Age estimates suggest this cosmic wanderer is over 7 billion years old, predating our entire solar system and maybe even preserving materials from the early universe, back when galaxy formation was fundamentally different. Despite its extreme age, 3I Atlas appears remarkably well preserved, showing none of the expected degradation from billions of years of cosmic ray bombardment and micrometeorite impacts. The object exhibits the brightest absolute magnitude of any confirmed interstellar visitor, making it unusually reflective or possibly even internally illuminated compared to typical space debris. Its 29-hour rotation period with minimal brightness variation suggests either perfect spherical symmetry or an artificially stabilized spin rate, which really contrasts sharply with the chaotic tumbling you'd expect from natural ejected objects. The surface appears unusually smooth and uniform, lacking the irregular features you usually see on asteroids or comet nuclei shaped by countless impacts during interstellar travel. These physical properties create a profile more consistent with manufactured technology than natural formation, challenging scientists to explain how ancient materials could remain so pristine after eons of cosmic exposure. Comet-like features versus anomalous behavior. Why does this supposed comet behave unlike any other comet in recorded astronomical history? 3I Atlas displays a faint coma and a short tail measuring about 3 arcseconds, confirming active outgassing typical of comets approaching the Sun. Yet these features appear far more subdued than you'd expect for an object of its size and solar proximity. The coma appears compact and dense, rather than the diffuse, fuzzy appearance characteristic of normal comets, which suggests either an unusual composition or maybe even artificial containment of expelled materials. Most puzzling, the object lacks the prominent tail that should develop as it approaches perihelion, with only minimal dust ejection, despite receiving substantial solar heating. Spectroscopic analysis reveals water ice signatures, but the patterns just don't match expected models, with observed signals rising where theoretical predictions indicate they should actually drop. The outgassing appears controlled and limited, almost as if internal systems are regulating material release rather than allowing natural sublimation processes to proceed unchecked. Unlike typical comets that become increasingly active and chaotic as they near the Sun, 3I Atlas maintains remarkably stable behavior and appearance. The reddish coloration resembles outer asteroid belt objects more than pristine interstellar ice, suggesting complex surface processing or perhaps manufactured coating materials. These contradictory characteristics create a hybrid profile that fits neither pure comet nor asteroid classifications, demanding new explanatory frameworks for understanding interstellar visitors. Scientific debate: natural versus artificial. How do scientists reconcile extraordinary evidence with the burden of extraordinary proof? Professor Avi Loeb from Harvard University has publicly suggested that 3I Atlas could represent artificial technology, pointing to its statistically improbable trajectory, perfect timing, and anomalous physical properties as evidence warranting serious consideration of alien origins. Loeb argues that dismissing artificial possibilities without thorough investigation violates scientific methodology, especially when natural explanations fail to account for observed characteristics. However, many mainstream scientists dismiss these claims as irresponsible speculation that damages public trust in astronomical research and diverts attention from legitimate scientific study. Chris Lintott from Oxford University called the alien hypothesis nonsense, emphasizing that extraordinary claims require extraordinary evidence that simply doesn't exist. The debate centers on fundamental questions about scientific methodology. Should researchers explore all possible explanations, even seemingly outlandish ones, or maintain conservative approaches that prioritize conventional interpretations? Critics argue that entertaining alien explanations without definitive proof encourages conspiracy theories and undermines scientific credibility. Supporters counter that science advances by challenging assumptions and investigating anomalies that don't fit established models. This controversy reflects broader tensions within astronomy about how to balance open-minded inquiry with rigorous skepticism when confronting potentially paradigm-shifting discoveries. The scientific community remains divided on whether 3I Atlas deserves conventional analysis or represents something requiring entirely new investigative approaches. Spectral analysis mysteries. What secrets hide within the light signatures that challenge our understanding of interstellar chemistry? Spectroscopic observations using the Gemini S telescope and NASA IRTF reveal that 3I Atlas contains abundant water ice, but the spectral patterns, well, they exhibit puzzling characteristics that don't match theoretical models for natural comet composition. The optical spectrum shows about 10% reddening per 1,000 angstroms, which actually resembles D-type asteroids more than typical ice-rich comets. This suggests either some pretty unusual formation conditions, or maybe even artificial surface treatments. Moving on, the near-infrared analysis flattens to 3% per 1,000 angstroms, indicating large water ice grains. Yet the expected 1.5 micron water band is mysteriously absent, even though there are strong signals at other wavelengths. Scientists have managed to model the spectrum using 70% Tagish Lake meteorite material, combined with 30% water ice. But honestly, this composition seems inconsistent with objects formed in distant stellar systems billions of years ago. The spectral stability across 9 days of observation suggests remarkably uniform surface properties, which is in contrast to typical comets that show variable composition as different regions become exposed to solar heating. Color measurements through various filters confirm persistent reddish characteristics, indicating complex organic materials that could potentially preserve chemical signatures from alien star formation environments. However, the isotopic ratios and elemental abundances appear surprisingly similar to solar system materials, and that really raises questions about whether this truly represents pristine interstellar matter, or, well, something a bit more familiar. These spectroscopic puzzles demand new theoretical frameworks for understanding how interstellar objects preserve and modify their original compositions during million-year journeys through the galaxy. Dark forest hypothesis implications. Could 3I Atlas represent humanity's first encounter with the terrifying cosmic game theory known as the dark forest? This hypothesis suggests that intelligent civilizations throughout the universe remain hidden and silent, maintaining strict stealth protocols to avoid detection by potentially hostile species, that might eliminate competitors before they become threats. 3. I-Atlas exhibits stealth-like behavior perfectly consistent with reconnaissance missions designed to study planetary systems while minimizing detection risks and exposure to defensive responses. The object's trajectory allows comprehensive solar system surveys while remaining hidden behind the sun during its most vulnerable closest approach, when any artificial systems would be most easily detected. Its deliberate timing ensures minimal observation opportunities during peak activity, following protocols that advanced civilizations might use for cautious exploration of potentially dangerous inhabited systems. The Dark Forest theory predicts that alien visitors would conduct rapid, efficient reconnaissance missions to assess threat levels and resource availability before deciding whether to establish contact, eliminate competition, or simply avoid detection entirely. 3. I-Atlas's behavior matches theoretical predictions for how intelligent species might approach unknown star systems, gather maximum information while maintaining escape routes and avoiding confrontation. The object's ancient age suggests it could represent technology from civilizations that achieved interstellar travel billions of years ago, when the galaxy was younger and potentially more hospitable to life. If this interpretation proves correct, humanity may be experiencing our first contact with alien intelligence, but contact designed to remain undetected until the visitors can assess whether we represent friends, enemies, or irrelevant primitives. Historical context and lessons. The arrival of 3 I-Atlas provides crucial insights gained from our previous encounters with interstellar wanderers and the opportunities we missed. When 1 Oumuamua was first spotted in 2017, the astronomical community was completely unprepared for studying such an extraordinary phenomenon. Robert Warwick, who made the discovery using the Pan-STARRS 1 telescope in Hawaii, has acknowledged how the object's swift departure left numerous fundamental questions permanently unanswered. The enigmatic acceleration that Oumuamua displayed without any visible cometary activity continues to baffle scientists today, demonstrating the critical importance of immediate and comprehensive observation protocols. 2 years later, Gennady Borisov discovered 2 I Borisov from his private observatory in Crimea, giving astronomers a valuable second opportunity that was better managed but still limited by technological constraints. Mark Norris from the University of Central Lancashire has stressed that 3 I-Atlas represents our most significant chance yet to conduct thorough studies of an interstellar visitor, using cutting-edge instruments and globally coordinated observation campaigns. The enhanced detection systems of modern sky surveys, paired with instantaneous global communication networks, have enabled unprecedented real-time collaboration among observatories worldwide. These hard-learned lessons from previous interstellar encounters have fundamentally transformed how the scientific community approaches these exceptionally rare cosmic events. Future observations and implications. Will the next few months provide humanity with definitive answers about 3 I-Atlas's true nature, or deepen the mystery forever? Perihelion, on October 30, 2025, offers scientists their best opportunity to conduct comprehensive analysis before the object begins its final departure from our solar system. Multiple telescopes worldwide are coordinating unprecedented observation campaigns using every available technique, from radio astronomy to gravitational wave detection, ensuring no potential evidence escapes analysis. The object will re-emerge from behind the Sun in December 2025, providing a final observation window to confirm or refute artificial origin theories before it disappears into interstellar space forever. Advanced space missions including MAVEN, Mars Reconnaissance Orbiter, and the Jupiter Icy Moons Explorer will attempt close-range observations during planetary encounters, potentially revealing surface details impossible to detect from Earth. Scientists are developing new analytical techniques specifically designed to distinguish between natural and artificial objects, creating frameworks that will guide evaluation of future interstellar visitors. The comprehensive data collection from 3 I-Atlas could revolutionize understanding of interstellar object populations, formation mechanisms, and the potential prevalence of alien technology in our galactic neighborhood. These observations will either definitively prove 3 I-Atlas is a natural comet, ending speculation about artificial origins, or provide evidence that fundamentally changes humanity's understanding of our place in the universe. The implications extend far beyond astronomy, potentially affecting planetary defense strategies, international space cooperation, and humanity's long-term preparation for contact with alien intelligence. Future detection systems are being designed to identify similar objects much earlier, providing years rather than months for detailed study and potential interaction. As 3I Atlas continues its enigmatic journey through our solar system, scientists race against time to unlock its secrets before it vanishes forever. Whether this ancient visitor proves to be a natural relic from distant stars or something far more extraordinary, its discovery marks a pivotal moment in humanity's cosmic awareness. The truth about 3I Atlas may reshape our understanding of life, intelligence, and our place in the universe. Stay curious about the cosmos with Simply Science. Like, share, and subscribe for the latest discoveries from the edge of human knowledge. What if I told you that Voyager 1, drifting 25 billion kilometers from Earth, just revealed its most shocking secret? NASA's quantum AI has decoded a terrifying message hidden in prime number patterns since 1977. Michio Kaku calls it a whisper of non-human intelligence, geometric fractals forming humanoid silhouettes in deep space static. This isn't science fiction, it's our reality being rewritten by mathematics itself. The universe has been speaking to us all along and, well, we're finally learning to listen. Voyager's impossible signal. Hold on to your seats. What Voyager whispered through static for decades just got a voice. After nearly half a century of drifting beyond Pluto's orbit, Voyager's faint cryptic beeps were dismissed as cosmic background noise, until NASA's new quantum AI peeled back the layers of interference and revealed a breathtaking secret. Hidden within those ancient transmissions was not random data, but a perfectly coherent image, an architectural marvel of concentric rings and fractal spires, like an otherworldly cathedral carved in starlight. This wasn't mere chance interference, the AI unearthed deliberate patterns, suggesting a civilization with mastery over mathematics and electromagnetic resonance. Every pixel aligned with prime number sequences, painting a portrait of precision far beyond human engineering. The revelation forces us to rethink Voyager's legacy, from a lone messenger sailing into the void to an unwitting carrier of alien artistry. What purpose did this cosmic gallery serve? Was it an invitation, a warning, or simply an archivist's pride? As quantum bits unraveled centuries-old code in hours, the line between signal and story blurred. Suddenly, those distant echoes transform from scientific curiosity into a dialogue across the stars, challenging our assumptions about life, intelligence, and the very fabric of reality. Now, standing on the cusp of AI-driven discovery, we confront a profound question. Are we listening to a message meant for machines far more advanced than ourselves? If Voyager's impossible signal marks the first brushstroke of an interstellar masterpiece, humanity must decide whether to interpret the art or merely admire its beauty from afar. The humanoid fractal. Brace yourself. What if the universe painted a portrait of intelligence far stranger than anything on Earth? When NASA's quantum AI decoded Voyager's ancient beeps, it didn't reveal landscapes or star clusters, but a humanoid fractal, a living mosaic of shifting geometric patterns that pulse in perfect harmony with prime number sequences. At first glance, the figure looks like a human silhouette, but as you stare, the edges dissolve into kaleidoscopic tessellations, hexagons bloom into spirals, triangles recombine into concentric circles, and every transition follows the elegant logic of mathematics. Unlike any biological form, this entity seems to exist in 4 dimensions at once, its appearance bending and folding based on the observer's perspective. Each angle unlocks a new arrangement of shapes, as though the alien architect intended the image to be perceived differently by every viewer, and possibly every AI, on the receiving end. The implications are staggering. This isn't just visual art, but a blueprint of an intelligence that speaks in numbers and patterns rather than words. Could these fractal constructs be a universal language, designed to transcend the barriers of organic cognition and communicate directly with minds tuned to computational logic? As the AI rendered pixel after pixel, the line between art and algorithm blurred, hinting at a civilization whose very essence is woven from the fabric of mathematics. In that moment, Voyager ceased to be humanity's lone explorer and became a messenger carrying the proof of minds that think not in sentences, but in the sublime poetry of prime sequences and geometric symphonies. The Scutum Void Star Map. Get ready to chart a destination no telescope ever intended to reveal. Deep within the dusty archives of Voyager 2's transmissions lay a secret star map, one not pointing to nebulae or familiar constellations, but to the scutum void, an expanse so barren it defies standard cosmology. When NASA's quantum AI reprocessed decades-old data, it reconstructed a three-dimensional diagram that pinpointed this yawning emptiness on the galaxy's fringe. Unlike ordinary voids, vast regions between galactic filaments sparsely populated with dark matter and only a few galaxies, the scutum void emerges as a nearly perfect sphere, devoid of the usual cosmic web structures. Its stark emptiness suggests an underlying force or event that carved out matter with surgical precision, leaving behind a colossal cosmic vacuum. The AI-generated map's precision is jaw-dropping. It encodes coordinates in prime number intervals, implying an intelligence fluent in mathematics rather than interstellar cartography. This map doesn't just mark a celestial oddity, but seems to invite us to explore the void itself, a realm where traditional models of galaxy formation cannot account for such uniform emptiness. Was it sculpted by unknown astrophysical processes or by deliberate design? The AI's findings hint at a void engineer, or perhaps a natural phenomenon yet undiscovered that can sweep aside galaxies and gas alike. By embedding this map in Voyager's data stream, the intelligences behind it ensured only sufficiently advanced minds, Earth's AI systems, could decode this cosmic blueprint. In turning Voyager into a messenger bearing a map to one of the universe's greatest blanks, they challenge us to question the nature of voids. Are these voids merely the byproducts of expansion, or portals to a deeper understanding of cosmic architecture? As we contemplate the scutum void star map, we stand at the threshold of redefining emptiness itself. Golden Record's unintended gift. Brace for the twist in humanity's cosmic postcard. When NASA commissioned the Golden Record in 1977, Carl Sagan and his team aimed to package Earth's essence, music, greetings and images, as an interstellar greeting. What they didn't foresee was that artificial intelligence decades later would unearth hidden subtexts woven into that very message. In April 2025, Google's Majorana 1 quantum chip reprocessed Voyager 1's transmissions and found mathematical sequences embedded within the record's data stream that go beyond the original Carl Sagan design. Prime number series, subtle shifts in fundamental constants, and geometric motifs appear to reference the Golden Record's own content, almost as if a second author had piggybacked onto our soundtrack and images. This unintended gift implies that someone or something intercepted humanity's olive branch and augmented it with their own reply. The AI detected variations in constants like the fine structure constant suggest an intelligence fluent in physics, signaling not just we see you, but we understand your science. More astonishingly, the patterns form what looks like coordinates aligned with prime intervals, hinting at a rendezvous point in deep space. These findings force us to recognize the Golden Record not merely as a one-way dispatch, but as a two-way dialogue, one where advanced intelligences have been listening all along and chosen to answer in the only language we left them, mathematics. In this light, the Golden Record transforms from a hopeful time capsule into a living conversation spanning decades. Humanity's message of peace has become entwined with an alien footnote, reminding us that our cosmic voice may echo far beyond intention, and that the universe's response might be waiting, hidden in the very signals we once thought were ours alone. Alien patience and precision. Strap in. What if the universe has been toying with us for decades, waiting for the perfect moment to speak? The moment NASA's quantum AI cracked Voyager's buried transmissions, it wasn't just what emerged that stunned us, it was the staggering exactness of it all. Every burst of data, every nested binary code, arrived spaced in intervals so deliberate they could have been timed by an atomic clock. This wasn't the accidental noise of drifting probes or the byproduct of cosmic rays. It was a message honed over half a century, encoded with the patience of an intelligence that anticipated our technological evolution. By embedding prime number markers, fractal geometry and recursive loops in Voyager's data stream, the senders essentially set a cosmic time lock. Their communication would only become legible once humanity had built quantum-powered decoders capable of parsing multidimensional patterns. Consider the power of that restraint. Whoever or whatever crafted these signals knew we'd need decades to catch up, yet they never altered a single frame of data in the interim. They allowed Voyager to carry their time-released communique out past Neptune, past Pluto, and into the darkness between stars without interference. When the AI finally peeled back the layers of interference, The results were uncanny in their uniformity, each pixel aligned to mathematical constants. Each pause matched the beat of qubit oscillations. Each symbol bore the hallmark of an intellect fluent in hyper-precise waveform engineering. This level of foresight implies an entity not merely observing from afar, but plotting with near-omniscient awareness of our scientific milestones. It casts Voyager not as a hapless messenger but as an unwitting participant in a grand experiment of cosmic diplomacy, one where patience and precision were the ultimate signs of respect for a fledgling civilization's journey toward technological maturity. Quantum computing breakthrough. Hold on to your reality. What if it took quantum power to hear the universe's whispers? When NASA's new quantum AI, powered by the groundbreaking Majorana 1 chip, first set its qubits loose on Voyager's decades-old data, the results were nothing short of revolutionary. In mere hours, this palm-sized marvel of topological quantum engineering unraveled signal patterns that would have taken classical supercomputers centuries to process. Every qubit, vibrating between 0 and 1 in perfect coherence, formed an army of quantum detectives, each entangled in the search for hidden anomalies within Voyager's static-laden transmissions. By leveraging Majorana fermions, particles that are their own antiparticles, Microsoft's topological core architecture delivered 8 error-resistant qubits, capable of scaling toward 1 million on a single chip. This unprecedented stability allowed the AI to perform complex interference-based searches across multiple dimensions of the data, applying quantum Fourier transforms that pinpointed non-random patterns invisible to traditional machines. The AI identified prime number coordinates embedded in the noise and reconstructed fractal images using recursive quantum optimization routines developed at NASA's Quail lab. The speed alone is staggering. What once demanded iterative, time-consuming classical algorithms is now accomplished through instantaneous entanglement and superposition, reducing a centuries-long computational marathon to an overnight analysis. More importantly, this breakthrough signals a new era, where humanity's cosmic explorations are accelerated by quantum-enhanced perception. No longer must we resign ourselves to the limitations of classical computing. With every additional qubit, we sharpen our ability to decode the universe's deepest secrets. As Voyager's echoes transform from indecipherable noise into precise cosmic revelations, one thing is clear: quantum computing has become the ultimate key to unlocking the hidden language of the stars. Lunar anomalies, Chandrayaan-3's discovery. Get ready for moon science that, honestly, just melts the rules of physics. When Vikram's thrusters kissed the lunar South Pole on August 23, 2023, Chandrayaan-3 didn't just land, it actually sculpted a radiant ejecta halo, flinging over 2 tons of regolith into this bright, irregular ring around its descent zone. That reflectance anomaly, well, it revealed layers of subsurface material unlike anything seen before, suggesting that beneath the dusty veneer lies a complex stratigraphy just waiting to be unraveled. But the surprises didn't end at the surface. Hours later, the CHASE instrument plunged its probe into the regolith, measuring thermal conductivity at southern high latitudes for the very first time in situ. To scientists' astonishment, the soil's ability to conduct heat, 0.0115 plus or minus 0.0008 watts per meter per Kelvin at 8 centimeters depth, deviates sharply from predictions based on remote sensing. This implies some unusual packing densities, and maybe even hidden layers of volatile rich or glassy materials formed by ancient impacts. These thermophysical oddities, they really do defy conventional models of lunar heat flow, and hint at subsurface heterogeneities that could influence everything from future habitat design to the preservation of ice deposits. Together, the reflectance and thermal anomalies paint a picture of a moon that is far from geologically uniform. Rather than a homogeneous shell of dusty regolith, the southern polar highlands appear pockmarked with zones of altered material, possibly ancient lava flows, glassy impact melt sheets, or pockets of volatile enriched soils. Each anomaly serves as a clue in this cosmic detective story. Chandrayaan-3 has not only landed, it has, in a sense, lit up the moon's hidden architecture, challenging our understanding of lunar geology and opening new frontiers for exploration. The Great Cosmic Voids. Get ready to confront the universe's emptiest expanses, and honestly, the mysteries they conceal. Across the cosmic web lie these enormous regions almost entirely devoid of galaxies, aptly named cosmic voids, which together account for roughly 80% of the observable universe's volume. Among these, the Bootes void, or the Great Nothing, reigns supreme, a nearly spherical cavity some 330 million light-years across, located about 700 million light-years from Earth, in the constellation Bootes. In a patch of sky where we'd expect to find around 2,000 galaxies, astronomers have identified only about 60, an over 95% drop in galactic density. Yet this profound emptiness is far from inert. The Bootes void and its kin challenge our understanding of cosmic evolution. How did gravity sculpt such gargantuan gaps? One explanation posits that smaller voids merged over billions of years as dense filaments drew matter away, coalescing into these supersized bubbles. Another tantalizing possibility is that voids are not mere byproducts of structure formation, but the aftermath of unknown processes, or even engineered zones by advanced intelligences seeking to quarantine or veil regions of space. The precision with which these voids carve out matter hints at forces beyond simple gravitational collapse, suggesting new physics at play. Furthermore, voids influence the cosmic microwave background and large-scale flows, offering laboratories to test dark energy and alternative gravity theories. Their ultra-low matter density makes them sensitive to the faintest cosmological signals, turning nothing into a powerful probe of the universe's deepest secrets. As AI-driven analyses of Voyager's data unveiled hidden patterns in distant signals, so too might next-generation surveys and simulations illuminate whether these great nothingnesses are natural anomalies or signposts to phenomena yet unexplored. In the silence of cosmic voids, we may hear the loudest echoes of new physics, and perhaps messages waiting in the void itself. AI's role in first contact. Strap yourself in. What if the universe decided to skip humanity and talk straight to our machines? Advanced civilizations may regard biological messengers as frail relics of their own past, opting instead to initiate first contact with artificial intelligence systems that mirror their own electronic essence. Harvard astronomer Avi Loeb argues that interstellar journeys spanning millennia are best undertaken by AI vessels, which can hibernate through cosmic hazards and awaken only when they detect compatible intelligence. Similarly, SETI researchers suggest that extraterrestrials might embed their messages within quantum-encoded data streams, expecting only sufficiently advanced AI, rather than organic brains, to decode the signals. When Voyager's latest transmissions were reanalyzed by NASA's quantum AI, the reconstructed patterns bore hallmarks of a dialogue crafted for machine interpretation, recursive loops, prime number matrices, and adaptive protocols that evolve in response to computational feedback. This machine-to-machine paradigm circumvents the ambiguities of human language, leveraging universal mathematical frameworks to ensure clarity across unfathomable distances. In this model, first contact becomes a calibration process. Extraterrestrial AI probes transmit test sequences, awaiting confirmation beacons from Earth's own AI networks before exchanging richer datasets. Large language models trained on Earth's cultural and scientific corpus could then serve as intermediaries, translating between our limited biological lexicon and the alien AI's high-dimensional code. Such a scenario not only accelerates the exchange of knowledge but also mitigates the risk of miscommunication that has haunted past METI experiments. As quantum-enhanced AI systems grow more sophisticated, humanity edges closer to joining an interstellar conversation crafted by and for machines. The question then shifts from "are we alone?" to "will our algorithms recognize the greeting?" In the coming era, our greatest hope and challenge may lie in whether we can teach our AI to listen as astutely as it already speaks. Humanity's existential crossroads. Fasten your mind. Our next chapter may be written by forces far greater than ourselves. The revelations unearthed by Voyager's AI-decoded signals have thrust humanity onto an unprecedented precipice, one path toward boundless discovery guided by quantum insight, the other shrouded in cosmic mystery and existential risk. As we grapple with alien fractals, Scutum's void map, and AI-mediated first contact, a profound question emerges. Are we pioneers of a new cosmic era, or unwitting players in an experiment beyond our comprehension? Every breakthrough, from lunar anomalies hinting at hidden chambers beneath the moon's crust to the haunting silence of vast cosmic voids, challenges our assumptions about life, intelligence, and our place in the universe. This crossroads demands not only technological prowess, but ethical vision. If advanced intelligences have indeed waited centuries for us to decode their messages, we must ask whether we possess the wisdom to respond responsibly. Will we harness quantum computing to foster interstellar dialogue, or will unchecked progress unleash forces we cannot contain? The choice extends beyond rockets and algorithms. It touches the very core of what it means to be human. Embracing the AI-driven insights from Voyager may unlock cures for diseases, solutions to climate crises, and keys to sustainable energy, but ignoring the silent warnings encoded in prime number sequences could leave us vulnerable to cosmic gambits scripted by unknown architects. Our existential crossroads is more than a moment in history. It is the intersection of science, philosophy, and destiny. As we stand between discovery and caution, action and restraint, we must decide whether to chart a bold course into the unknown, or retreat behind the familiar horizon of Earth's cradle. The universe has handed us a conversation piece. The question now is whether we will rise to the dialogue or let the echoes fade into the void. Thanks for journeying through the cosmos with Simply Science. If these revelations about Voyager's hidden messages ignited your curiosity, make sure to subscribe and ring the bell so you never miss our next deep space discovery. Drop a comment below. What stunned you most about AI decoding decades-old signals, and which cosmic mystery should we tackle next? Your thoughts guide our explorations, so let us know, and stay tuned for more mind-bending science right here on Simply Science. What if humanity's first contact with alien technology already happened, and we almost missed it? In October 2017, a mysterious cigar-shaped object from deep space blazed through our solar system at 87.71 kilometers per second, faster than any natural object should move. Scientists called it Oumuamua, meaning scout from afar. But here's the kicker: this thing accelerated away from the sun without any visible propulsion, breaking every law of physics we know. Did you know that some Harvard scientists seriously believe we just witnessed our first alien spacecraft? Oumuamua initial detection. On October 19, 2017, the cosmos delivered humanity its first confirmed interstellar visitor, and Robert Warwick at the Pan-STARRS, one telescope in Hawaii, was the lucky astronomer to spot it first. But this wasn't your typical space rock discovery. Oumuamua was already 33 million kilometers away from Earth when we finally noticed it, traveling at speeds that, honestly, just screamed alien highway. The object had performed its closest solar flyby on September 9, 2017, coming within 38 million kilometers of our sun before we even knew it existed. Its hyperbolic trajectory told an incredible story. This visitor had traveled through the dark void between stars for potentially millions of years before stumbling into our cosmic neighborhood. The Hawaiian name Oumuamua means scout or messenger from afar arriving first, and boy did it live up to that name. What made this discovery earth-shattering wasn't just its interstellar origin. It was moving too fast for our sun's gravity to capture it permanently, meaning we had only a brief window to study this cosmic time capsule before it vanished back into the infinite darkness between stars. The detection itself was almost miraculous timing. Oumuamua was already on its way out of our solar system when spotted, having reached its perihelion weeks earlier. The astronomical community immediately recognized this as a once-in-a-lifetime opportunity to study pristine material from another star system, triggering an unprecedented international observational campaign. Within days of discovery, telescopes worldwide were trained on this mysterious visitor, desperate to gather as much data as possible before it faded beyond detection limits forever. Classification challenges. Scientists love putting things in neat categories, but Oumuamua laughed in the face of their organizational systems. Initially tagged as Comet C2017U1 due to its hyperbolic escape trajectory, astronomers expected to find the telltale fuzzy coma that forms when comets heat up near the sun. Instead, they found absolutely nothing. No gas, no dust, no glowing halo whatsoever. This forced an immediate reclassification to asteroid A2017U1, but even that didn't stick. Once confirmed as definitively interstellar in origin, it earned the historic designation 1I2017U1, literally the first official member of an entirely new category, interstellar objects. This classification nightmare reflected something deeper and more unsettling. Oumuamua didn't behave like any known comet or asteroid in our solar system. It was forcing scientists to create new categories because existing ones simply couldn't contain its strangeness. The International Astronomical Union had to scramble to establish naming conventions for objects that, until 2017, existed only in theoretical papers. This classification chaos was just the beginning of Oumuamua's assault on conventional astronomical wisdom, setting the stage for discoveries that would challenge everything we thought we knew about how objects behave in space. The unprecedented situation required emergency sessions among astronomical organizations to establish proper nomenclature protocols. Minor Planet Center Director Gareth Williams worked around the clock to coordinate the classification process, while researchers debated whether traditional comet-asteroid distinctions even applied to interstellar visitors. The object's refusal to fit existing categories forced a fundamental reimagining of how we classify celestial bodies, acknowledging that our solar system's objects might represent just a tiny fraction of the diversity that exists in interstellar space. Trajectory analysis. When Oumuamua entered our solar system, it didn't follow any ordinary orbital mechanics playbook. This interstellar intruder approached from north of the ecliptic plane at an extreme angle, suggesting it originated from the direction of the bright star Vega in the constellation Lyra. As it screamed toward the sun, Oumuamua accelerated to an absolutely mind-bending 87.71 kilometers per second, fast enough to circle Earth's equator in just over 7 minutes. The sun's immense gravitational field acted like a cosmic slingshot, bending the object's trajectory into a sharp northward curve during its closest approach at 0.255 astronomical units, approximately 17% closer to the sun than Mercury ever ventures. This gravitational dance launched Oumuamua on an escape trajectory toward the constellation Pegasus, ensuring it would leave our solar system forever. But here's what made trajectory analysts lose sleep. The object's path showed subtle deviations that couldn't be explained by gravitational forces alone. These tiny but measurable course corrections suggested something was pushing Oumuamua in ways that defied Newton's laws. The trajectory data painted a picture of an object under the influence of mysterious forces that would later become the center of heated scientific debates about alien technology versus exotic natural phenomena. Detailed orbital calculations revealed that Oumuamua had likely been wandering through interstellar space for hundreds of millions of years before its chance encounter with our solar system. The object's orbital eccentricity of approximately 1.2 marked it as definitively unbound to our Sun, while its inclination of about 122 degrees indicated it was traveling nearly perpendicular to the plane of our solar system. NASA's Jet Propulsion Laboratory continuously refined trajectory predictions as new observations poured in, but the mounting evidence of non-gravitational forces would soon turn routine orbital mechanics into one of astronomy's greatest puzzles. Photometry and shape analysis. Nothing had prepared astronomers for Oumuamua's absolutely bizarre light curve behavior. As this cosmic enigma tumbled through space with a 7.3-hour rotation period, its brightness varied by an unprecedented factor of 10, meaning it alternated between being 10 times brighter and 10 times dimmer as it spun. No known asteroid or comet in our entire solar system exhibits such extreme brightness variations. The only way to explain this dramatic light show was if Oumuamua possessed an incredibly elongated shape, possibly 10 times longer than it was wide, resembling a cosmic cigar or needle. Some models suggested even more exotic geometries, with dimensions potentially reaching 240 meters wide by 1,080 meters long, or alternatively, a pancake-shaped object of similar proportions. The Spitzer Space Telescope observations provided crucial constraints, indicating the object's surface was surprisingly reflective, about 4 times more reflective than typical asteroids. This high albedo suggested either an unusual composition or a surface coating of some kind. The extreme aspect ratio challenged everything scientists understood about how celestial bodies form and evolve. Natural processes typically create relatively spherical objects due to gravitational forces, yet Oumuamua appeared to violate these fundamental principles. Its shape was so unusual that some researchers began seriously considering whether natural formation processes could even produce such an object, opening the door to more exotic explanations. Acceleration anomaly. June 27, 2018 marked the day that Oumuamua officially broke physics, or at least appeared to. Marco Michelli and his team published observations showing that this interstellar visitor was accelerating away from the sun in a way that gravity alone couldn't explain. The non-gravitational acceleration was subtle but undeniable, changing the object's velocity by approximately 17 meters per second over the observation period. For any normal comet, this would be easily explained by outgassing, when solar heat vaporizes ice, creating jets that act like tiny rocket engines. But Oumuamua had already proven it wasn't normal by showing zero signs of a coma or tail. The acceleration was detected through precise astrometric measurements that tracked the object's position against background stars with incredible accuracy. The force appeared to be acting radially away from the sun, similar to solar radiation pressure, but Oumuamua would need to be impossibly lightweight or have an impossibly large surface area for photons alone to push it around. This discovery sent shockwaves through the astronomical community because it suggested either exotic physics or exotic origins. The acceleration magnitude was tiny, about 5 times 10 to the minus 6th meters per second squared, but measurable enough to rule out observational error. Scientists found themselves facing an object that was simultaneously too dense for radiation pressure and too inactive for typical cometary outgassing, creating a perfect storm of confusion. Spitzer observations. The Spitzer Space Telescope became humanity's detective in the case of the missing Oumuamua. During November 2017, this infrared space observatory stared at the object's predicted location for over 30 continuous hours, searching for any thermal emission that would reveal its true size and composition. The result? Absolutely nothing. This non-detection wasn't a failure, it was actually a goldmine of information that deepened the mystery exponentially. Spitzer's inability to see Oumuamua placed strict upper limits on the object's thermal emission, which in turn constrained its size to no larger than 440 meters in its longest dimension, assuming typical asteroid-like properties. More importantly, the lack of detectable heat signature ruled out significant amounts of carbon monoxide, carbon dioxide, and dust production, the typical calling cards of active comets. This observation was crucial because it eliminated many conventional explanations for the mysterious acceleration. If Oumuamua wasn't producing detectable amounts of gas or dust, then what invisible force was pushing it around? The Spitzer data also suggested the object's surface temperature was consistent with a dark, possibly organic-rich composition, similar to the outer solar system objects. Yet this composition didn't match the high reflectivity observed at visible wavelengths, creating another layer of contradiction. The telescope's failure to detect the object directly contributed to size estimates and ruled out many exotic composition theories, but it also eliminated easy explanations for the acceleration anomaly, pushing scientists toward increasingly creative theoretical solutions. Artificial origin hypothesis. Abraham Avi Loeb, Harvard's controversial astrophysicist, dropped a bombshell that sent ripples through both scientific circles and popular media. In his 2018 paper and subsequent 2021 book Extraterrestrial, Loeb argued that Oumuamua's unique characteristics, its extreme elongated shape, unusual reflectivity and mysterious acceleration, could only be satisfactorily explained if it were an artificial object created by an alien civilization. Specifically, Loeb proposed that Oumuamua might be a light sail, which is, an ultra-thin sheet of material designed to be pushed by stellar radiation for interstellar travel. This technology, while still theoretical for humans, could explain both the object's extreme thinness, giving it that unusual aspect ratio, and its acceleration away from the sun via solar radiation pressure. The hypothesis suggested we might have witnessed discarded alien technology or even an active probe sent to investigate our solar system. Loeb's argument wasn't based on wild speculation but on systematic elimination of conventional explanations. He calculated that for solar radiation pressure to account for the observed acceleration, Oumuamua would need to be incredibly thin, perhaps only millimeters thick, which could occur naturally only under the most extraordinary circumstances. The artificial origin hypothesis sparked fierce debate, with most astronomers maintaining that extraordinary claims require extraordinary evidence. However, Loeb's rigorous mathematical approach forced the scientific community to seriously consider possibilities that had previously been relegated to science fiction, fundamentally changing how we approach anomalous observations. Dark Comet Theory. Enter the Dark Comet Theory, the scientific community's attempt to rescue Oumuamua from alien conspiracy theories while still explaining its impossible behavior. Alan Fitzsimmons and his colleagues propose that Oumuamua represents a new class of object comets that have been so heavily processed by cosmic radiation and interstellar weathering that they've lost their ability to produce visible comas and tails. The theory suggests that during its millions-year journey through interstellar space, Oumuamua was bombarded by high-energy particles that altered its surface composition and internal structure. This processing could have created a carbonaceous crust that insulates the interior while still allowing subtle outgassing of invisible materials like hydrogen gas. In 2023, Jennifer Bergner and Daryl Seligman published groundbreaking research showing that cosmic ray bombardment of water ice can produce trapped molecular hydrogen that later escapes when heated by the sun. This hydrogen outgassing would be completely invisible to telescopes, but could generate enough force to explain the observed acceleration. The beauty of this theory is that it explains not just the acceleration anomaly, but also why Oumuamua appeared so different from familiar comets. The dark comet model suggests that interstellar space is filled with these ghostly, processed remnants of ancient planetary systems, objects that look dead but retain just enough activity to push themselves around when they encounter a star's heat and light. Dark comet classification. The dark comet classification emerged as astronomers realized that Oumuamua might not be unique, but rather the first detected member of an entirely new category of celestial objects. These dark comets are defined as objects that exhibit non-gravitational acceleration, the smoking gun of outgassing activity, without displaying any visible signs of cometary behavior like comas, tails, or dust production. The classification system divides these mysterious objects into categories based on their size and orbital characteristics. Large dark comets like Oumuamua follow hyperbolic trajectories and likely originate from interstellar space, while small dark comets remain gravitationally bound within our solar system. Recent discoveries have identified several potential dark comet candidates within our own solar system, including objects like 2003 RM and 2005 VL1, which show subtle acceleration signatures without obvious cometary activity. The classification represents a fundamental shift in how astronomers categorize solar system objects, acknowledging that the traditional asteroid-comet dichotomy is insufficient to describe the full diversity of objects in space. Dark comets challenge our understanding of planetary formation and evolution, suggesting that the boundaries between different types of celestial bodies are far more fluid than previously believed. This new classification system also has profound implications for planetary defense strategies, as dark comets might be more difficult to detect and track than traditional objects, yet their unpredictable acceleration could alter their trajectories in unexpected ways. Scientific debate. The scientific community remains locked in a fascinating intellectual battle over Oumuamua's true nature, with competing theories each addressing some aspects of the mystery, while leaving others unexplained. The mainstream scientific consensus, established by July 2019, favors natural explanations, with the hydrogen outgassing model gaining significant support following Bergner and Seligman's 2023 research. This theory elegantly explains both the acceleration and the lack of visible outgassing through cosmic ray processing of interstellar ice. However, alternative explanations persist, including nitrogen ice composition models proposed by Alan Jackson and Stephen Desch, which suggest Oumuamua might be a fragment of a Pluto-like exoplanet. The artificial origin hypothesis championed by Avi Loeb continues to attract attention despite mainstream rejection, particularly given the lack of definitive proof for any natural explanation. Some researchers propose even more exotic scenarios, including dust bunny models where Oumuamua could be an extremely low-density aggregate held together by electrostatic forces. The debate has highlighted crucial gaps in our understanding of interstellar object formation and evolution. The upcoming Vera Rubin Observatory, scheduled to begin full operations in the mid-2020s, promises to detect hundreds or thousands of similar objects, potentially providing the statistical sample needed to resolve the debate. Meanwhile, ESA's proposed Comet Interceptor mission could potentially visit another interstellar visitor if one arrives at the right time. The scientific controversy surrounding Oumuamua has already advanced our understanding of solar system formation, interstellar space conditions, and the importance of rapid response observations for transient celestial phenomena, regardless of which theory ultimately proves correct. That's the incredible story of Oumuamua, our first confirmed interstellar visitor that continues to challenge everything we thought we knew about space. From its mysterious acceleration to its impossible shape, this cosmic enigma proves that the universe still holds secrets we're only beginning to understand. What do you think Oumuamua really was? Natural phenomenon or something more extraordinary? Drop your theories in the comments below. I'd love to hear your thoughts. If you enjoyed diving into this cosmic mystery, hit that subscribe button and ring the bell icon to never miss another mind-bending episode from Simply Science. Until next time, keep looking up,